All right, so I'm going to go through these two examples real quick. So just like one of the things I didn't discuss in class, I don't remember saying it, so I'm just going to say it now. Just like when you have to factor, the quadratic equation has to be set equal to 0. So the first steps that we took when we were factoring and solving is going to be the same. So over here, I'm going to first subtract 1 from both sides. I get x squared minus 7x plus 11 equals 0. This is one of those where you definitely know it's not factorable and you would have to use the quadratic formula because there are no two numbers that are going to multiply to 11 and add to negative 7. So just keep that in mind. I think in class I talked about how there would be some where you might be able to use factoring, but this is definitely where more quadratic formula is your best option right now. So real quick, since there's no 1 here, I'll write it. So this is my a, right? A is 1. B is negative 7. C is 11. So I'm going to fill in my formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yep, I told you I was going to torture you guys with that song. So x equals, since b is a negative 7, then b, you can write it like this, right? Ultimately, you're going to change that to a positive 7 because 2 negatives. Plus or minus square root of negative 7 squared minus 4 times 1 times 11. And I'll divide it by 2 times 1. Simplify this out. I'm going to get 7 plus or minus the square root of 49 minus 44 all over 2. Subtract what's under the radical, and I get 7 plus or minus the square root of 5 over 2. If you remember from our example in class, we had the square root of 1, which we knew was a perfect square, so we could simplify that value. But here, since square root of 5 can't be simplified, we're just going to leave this guy as is. 7 plus or minus the square root of 5 over 2. Okay, that is our final answer. If I wanted a decimal approximation of what that is, I could throw this in the calculator and this in the calculator. And that would give you the opportunity to check with Desmos by looking at your roots, by looking at your x-intercepts on the graph. So just keep that in mind. You can get the decimal approximation and still check yourself with a graph that way. All right, let's look at this last one. This last one, we're going to get it equal to 0 first. So I'm going to subtract my 2x. I'm going to add my 6. Okay, I get 2x squared plus 3x plus 4 equals 0. So I've got my a is 2, my b is 3, my c is 4. And I'm going to plug in my formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's a 2. Ooh. So there is my formula with everything plugged in. I get negative 3 plus or minus the square root of 9 minus 4 times 2 times 3 is going to give me 24 over 4. If I simplify this out, this gives me negative 3 plus or minus the square root of negative 9 minus 24. 15 over 4. Now, this proposes a problem. This creates a non-real solution. We can't take the square root of a negative. That's an issue. So when we get a negative under the radical, note that this denotes a non-real solution. that means that on the graph, you won't see any x-intercepts. Now, for tonight, I only gave you one problem where I'm talking about non-real solutions, but tomorrow our whole focus is going to be talking about how do you express non-real solutions. We're going to talk about complex imaginary solutions, and we're going to kind of like tie these things together to see these. If you do get a chance, this first video we watched in class, this second video is my favorite video in the whole wide world. Watch it. It's great. This one is a good video too, but this one's my favorite right here. This one right here. Okay. Here's your questions that you're going to work through tonight. Note your answers are already there for you. Except for number 9, I told you that the answer was non-real, so I want you to explain to me how you know it's non-real. For 1 through 8, you're just going through and doing the problem, plugging in, making sure it's equal to 0, plugging in, evaluating. The big thing to remember is that you'll notice, especially for, this might be the only one, but for this one, you'll see 2 square roots of 3. Just remember what we talked about simplifying radicals in the past. You will need those skills in order to get to the answer that I've got written down here. All right, that is all.